This video shows different examples of automated object grabbing using a stereo vision in the hand of a robot. We show the ability of the system with objects of different sizes, objects on high and low shelves, as well as objects on the floor. We also show upright and lay-down objects. We also demonstrate how the GUI can be commanded using head tracking, speech, touchscreen, trackball, etc., thereby allowing disabled users with varying levels of disability to access the system. We also show the ability of our system to provide audio and video feedback to the user. Notice that all tasks are performed under natural lighting and in an unstructured environment with lots of clutter. Using a touchscreen, a user can manually select the object of their choice. Here we have a medium-sized object, in this case a remote control, located on a table of average height. Using gross motion, the arm moves and orients itself so that the remote is aligned with the image plane of the robot's visual system. Then, using fine motion, the arm tracks features on the object to carefully align its grip to properly pick up the item. Pictured here are some objects that are positioned on the floor, a task that is of much interest to disabled users in a wheelchair. The user wants to pick up the Nestle water bottle. After the user selection is made, one can see from the stereo matches on the slide how features on the relevant object have been selected through physical, geometrical, and statistical constraints. Using this 3D information, the robot performs gross motion to center the bottle and to get within a foot of the bottle for better object recognition. At this point, the object is identified by running segmented features in the center of the image against a template library. The query is run quickly through a large database by using a scalable vocabulary tree that we have implemented. The results of feature matching with the chosen template can be seen here. The arm then performs accurate translation and rotation motions. As we can see at the end of this motion, the live view is aligned with the grasping template. The arm then approaches the object, picks it up, and brings it back to a home position. Because the object is transparent as well as reflective, this is a challenging task. Here, once again, we have a medium-sized object, a remote, this time located at a lower height, similar to that of a coffee table. Gross motion is performed at first, and then the robot tries to align itself for the grab, as we can see in this view captured from the end effector mounted left camera. As in the previous case, the remote shows a bunch of reflection due to direct light. This time, the user has selected to pick up a much smaller item, a marker, that has been placed on a table of average height.
Object recognition. Object is identified. Start fine motion.
As can be seen, the arm easily recognizes the marker as a selected object and is not distracted by other nearby objects. The marker pen can be replaced with any similar object, like a lipstick, toothbrush, hairbrush, and so on. Shown here is a head motion tracking device with an infrared sensor and transmitter. On the user's hat, we see 3 pieces of reflective material. The reflective material will reflect IR beams, allowing for the head tracker to work. The head tracker allows users who may not be able to use their hands or voice to use head motions to select objects. Here we see the user moving their head from right to left. We can see the movement of the cursor on the live screen following the user's head. The reverse movement is shown here. The user indicates selection by a roll of the head, and feedback is provided to the user by a highlighted area on the live screen. In this case, the user has selected a Publix water bottle.
Start object recognition. Object is identified. Start fine motion.
Then, gross and fine motion stages proceed as previously explained.
Start approaching. Ready to different.
Should a user not be able to use a head tracker or their hands, the user may use their own voice. By using verbal commands, the arm is able to comprehend and execute the right actions.
Show auto,
Show auto.
coordinate,
Coordinate.
E and 3,
E and 3.
shift down,
Shift down.
shift
Here,
down,
the user is commanding the GUI to switch to the automatic mode and then turn on a grid.
Start growth motion.
The user can then select an object by calling an index into the grid. Indices are marked on the top and the right of the display. Audio feedback is given to the user to confirm what the robot heard. For commands that will initiate robot motion, the user needs to confirm commands through a single switch, such as a jelly
Start
switch.
object recognition.
This is for safety reasons, so the user does not inadvertently initiate motion. Here, we can see the arm performing under voice commands.
Start approaching. Ready to different.